All right, we are going to start Module 7 this week and learn all about properties of triangles. You've worked with, up until this point, a lot of right triangles when you're doing Pythagorean theorem and stuff. Now we're just going to kind of take general properties of all triangles and learn some more about those. All right, so our first lesson is in 7.1, interior and exterior angles. There's a handout in Schoology for you to follow along with this video, so you can take some notes and example problems. You also have a study guide, which there's a lot of different terminology and some theorems in this. So I just put them all together in that yellow sheet, which you should have. And I will, at the end of this video, there will be all of this stuff. So if you don't get it written down while I'm going through it, there'll be a chance for you to catch up at the end. All right, so our first term is an interior angle. Right? Interior means inside. So an interior angle is, in geometry terms, is an angle formed by two sides of a polygon with a common vertex. In regular terms, it just means the angle inside the shape. All right, we already talked about the triangle sum theorem a little bit with this last module. So the formal theorem, the sum of the angle measures of a triangle is 180 degrees. All right, so we can take this triangle sum theorem and apply it to different polygons. All right, so a polygon is just something bigger than a triangle. A triangle is a polygon also. So just two-dimensional shape, generic term, polygon. All right, so what we're going to do with these shapes is we are going to draw triangles and see how many triangles are in each shape and see if we can figure out the pattern. All right, so a quadrilateral has 4 sides. If I draw a diagonal in there, notice now I have 2 triangles. So this next one is a pentagon with 5 sides. Draw some diagonals. I've got 3 triangles. All right, this next one is 6 sides. We have a hexagon. I draw some diagonals in here. Notice I have 4 triangles. All right, the next one is 7-sided, which is a heptagon. Don't get too carried away on having to remember these terms. Okay, you can draw the diagonals in there differently, but you will still get the same amount of triangles. This one, in this case, has 5. All right, the next one is an octagon. So 8 sides. If I draw in the diagonals, I end up with 6 triangles. All right, so all of those triangles, if we add them up together, we can figure out how many degrees the interior angles will add up to. All right, so a pentagon has 5 sides, and we said that one had 3 triangles. A hexagon has 6 sides, we said that had 4 triangles. So if we take the number of triangles times 180, because each triangle has 180 degrees, we multiply that together, we will get a total of 540 degrees. If we do a hexagon with 4, so 4 triangles times 180 gives me 720 degrees. Okay, a decagon has 10 sides. All right, if you look at the pattern here, the number of triangles is 2 less than the number of sides. So a decagon is going to have 8 triangles. Take that times 180 degrees in each triangle, and we will get 1,440 degrees in a decagon. All right, so we can write this as a formula. Okay, the number of sides, which we call n, minus 2 for the triangles, times 180 will give us all of the interior angles all added together. So the sum of those measures, the interior angles, with n sides is n minus 2 times 180. All right, so some terms in this theorem. So convex simply means all the angles are less than 180 degrees. Okay, so there's a nice diagram on your formula sheet or your study guide that tells you the difference between a convex versus concave. Okay, so convex is all the interior angles are less than 180 degrees. Everything we're working with are going to be convex, so that this theorem applies. All right, a regular polygon means that all the sides are congruent and all the angles are congruent. So they all have the same measure. All right, this theorem does apply for irregular polygons, but when they talk about regular, you need to know that everything is going to be the same. All right, so using this theorem, all right, I have a shape here that has 9 sides, and I need to find the value of that missing angle. Okay, so I'm going to use this formula. So I'm going to take 9 minus 2 times 180 degrees. So 7 times 180 degrees gives me a total of 1260 degrees inside this 9-sided polygon. All right, now I'm going to add up all of the angles that I'm given, which, when I add them all up, I get a total of 1102 degrees. Okay, so if I take my total that I should have minus what I do have, you end up with x is equal to 158 degrees is what's left. All right, so we're going to be using this theorem a lot. Really, just this formula. Do some practice with it. Oh, before we get that. Okay, so this is where this regular convex comes into play. Okay, if we have a regular convex, that means all the sides, all the angles are the same. So I can take the number of sides of any regular polygon, subtract 2, that's from the theorem we just did, times 180 will give us the total degrees. We divide that by the number of sides in our polygon. It will tell us the degrees of all of the angles, because they're all going to be equal, so we divide that evenly. So that would be for our regular convex polygon. All right, I have a pentagon. So we have 5 sides. Okay, so to find the value of x, we need first of all figure out how many degrees are in the pentagon total. So 5 minus 2 times 180. So 3 times 180 gives us 540. All right, we need to add up what we have. So we have 90 plus 90 plus 90, which is equal to 270. So take our 540 degrees that it should be, minus our 270 degrees that we have, and we get 270 degrees. We have 2 missing angles that have the same measure. So if we divide 270 by 2, we get 135 degrees for each angle. So if we added all these up, so 135 plus 135 plus 90 plus 90 plus 90, we should get back to that 540 that we're supposed to have. All right, so another one. This time I don't have a shape drawn, but I'm told it's a hexagon, and I'm given the measure of all 6 angles. So what we need to figure out is what the value of b is. So we need to know how many degrees are in a hexagon. Well, we just figured this one out on page 4. Okay, 6 minus 2, so 4 times 180 gives us 720 degrees. Now we need to add up all of these measures that were given. So I've got 69 plus 108 plus 135 plus 204. Plus I also have a b and a 2b. And when I add all those together, I need to get to 720. All right, so I can simplify this. I can take and add that up. That's just a number. So this actually gives us 516. I can add together my b's. I've got 3 b's total. All right, now algebra, we're solving for b. So we need to subtract our 516. So we've got 3b equals 204 divided by 3. So b is equal to 68 degrees. All right, so we've got one measure. So 2b, which would be the other one. So multiply 68 by 2 to give us 136 degrees. Okay, so those are the missing angle measures. All right, we also have exterior angles and remote interior angles. So an exterior angle is formed if I extend the side of my polygon, that will make an exterior angle. The remote interior angles are the ones opposite that. So they're the ones that aren't going to touch that exterior angle. So for this one, angle 1 and angle 2, these are our remote interior angles. Angle 4 is our exterior angle. Angle 3 plus angle 4 is a straight line, so it's 180 degrees. All right, this theorem, there's a theorem about these that says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So what this means is if I add the remote interior angles together, so the exterior angle across from them will be those added together. So in this case, it would be 100 degrees. All right, so we're going to do some practice with these. So if I want to find the measure of angle B, I know that if I add 5z minus 2 plus 2z, so if I add the remote interior angles together, they will be equal to the exterior angle across from them. So now solve this with some algebra. So I've got 7z minus 2 equals 145. Add 2. Oops, that's 2. 7z equals 147 divided by 7. And we end up with z is equal to 21. All right, we're not done. We actually need the measure of that angle. So we're going to put it back into that formula. So 5 times 21 minus 2 will give us 103 degrees. That's the measure of angle B. All right, one more. So this time I don't have the angle measure of my remote exterior, but I know that it's equal to the sum of those, or the remote interiors. Okay, Q is a 90-degree angle. All right, again, we're going to solve some algebra here. So we've got 3x equals x plus 100. We need to get all the x's together. So we've got 2x equals 100. 1x has to equal 50. We're looking for the remote the exterior angle measure. So we're going to take 3 times 50 minus 8, which will give us 142 degrees. All right, so finding the angles of a polygon and then either the exterior or the remote interior angles is what we're doing today. Your assignment is either the PDF that's in Schoology, or you can do IXL G4 to 80. This will also be in updates. If you don't remember what that is, you can pause the video and just leave this up, make sure everybody has it written down.